started the class.
Yes.
Oh! Let me go have a shot.
Oh my god. Yo. It's like the stance. He has like the whole like trajectory. I'm gonna go for a point.
Any students interested in participating?
Oh, it's hard. It's hard. It's not easy.
Okay, last one. Because keep thinking, oh, it's easy. You have these guys in the way. So yesterday.
Come out to the gym today.
For after class.
Okay, yeah, that's out. Let's not throw it away. Oh my god. I have a video of it. Did you actually capture it bouncing? Yeah, I literally captured like the details.
Oh yeah, and what was your caption on Snapchat, Hashim? What was your caption on Snapchat?
That's a lie. I don't have any social media. Oh,
all right. You write mine, I write yours. They're like cute, but it's like a couple you never expected. Because they're like, they were like best friends. Yeah. I didn't see it until like
They're just throwing out
can you guys type Control T. What does Control T do? Okay, Control T. Oh no. I don't want Control T. I need this. Control 1. Really? It goes to the first tab.
Control and then whatever number, it goes to the number.
Okay. Alright, search drive. Code. Day 57. Go to the 80.
How far can it go?
Yeah, exactly. Scroll down. Yeah, this is good. Okay, we'll do this. Okay, guys. I encourage you to take out your calculators. Guys, take a calculator only if you left one to charge. Don't take a calculator if you did not leave one here. So we'll do some word problems, calculator related problems.
Hello there.
Mr. Balthazar.
Wow, how cute.
What's cute? You're just using my vocabulary.
Yeah, he is in there.
Who has my mouse? Okay, stay with me, please. Yeah. Take out a calculator. We're doing some word problems. Guys, on your final, you have about 4 of these word problems out of the 10 or 12 we've discussed, all right? But relax, I'll kind of walk you through it. So we're doing a review. Mr. Campos, you're there?
Yeah.
All right, are you able to see the board?
Okay. Now I'm recording anyways.
All right, have a look at question number 1, please.
Oh, it's right there, so you're gonna.
What's right there?
It's recording. So.
Oh, this one too? Yeah. Who's this?
That's my phone.
Oh, you're just recording it for the sake. All right.
Kind of just.
All right. Read the problem with me, please. Shh.
Do you want us to write it down?
No, you don't need to write it down. Just read the problem. So it says, as part of an experiment, an alloy is being heated. That is an actual AP release problem, by the way. The table below gives the temperature W of T of an object at time T. Suppose that W of T is continuous and differentiable over the interval 0 to 20. So this is the temperature function. This is not the rate, this is the temperature function. Please understand that. All right, you don't need to copy anything unless you want to. Now let's read the problem. It says, estimate W dash of 5 and interpret it. So keep in mind I've given you points. So I need W dash of 5. Does anybody remember how to do it? I need the slope at 5, but I have values at 4 and 9.
Oh, between.
Thank you, MSEC.
Okay.
So we'll do part A. I don't know, maybe I should write here. So Mr. What's his name? Compost MC. So I need W dash of 5. See if this comes back to you. I'll write approximately because it's not the exact slope. So I need the slope at 5, so understand that. I need a slope at 5. I can't do MTAN, I don't have a curve, so I do MSEC. So approximately. Should I do 4 minus, 57.1. Can you see the Y values on top? Minus 61.8 over 4 minus 9. Shh. And that's negative 4.1. Yes? On top. Negative 4.1 over negative 5, which is 4.1 over 5. I could simplify this in my head if I wanted to. Like, is that 41 over 50? Anyway, I just moved the decimal over. But you can use a calculator, it's not a big deal. Let's get the units right. What's the unit of the numerator? Degrees Fahrenheit. What's the unit of the denominator? Minutes. Okay. So it says estimate W dash 5. And there's a second part. It says interpret. So I'm giving you 30 seconds of thinking time. Keep in mind W is the temperature. And at 5, see if you can write a sentence. Indicates that this is W dash of 5. And I'll give you a hint, it's a positive number. Mr. Naga says it's roughly 0.8. Okay, it's 0.802, I think. Okay, so you can, if you want to, you can make it 0.80.
41 over 5. 41 over 82. Just times by 2.
82?
Over 100. 82.
Yeah. So see if you can interpret it yourselves. I'll do it in a second, but I want you to have an independent shot.
You need to log in to your variables.
Oh, it's already logged in actually.
No, I think it says it's from
No. Here's the
Oh.
and then I'll continue again. Okay, stay with me. Okay, does anybody remember I want to have a shot? Again, one of these word problems will be, these kind of word problems. Anybody? Indicates that. Okay, at equal to 5 or at 5 minutes, go on.
The temperature is rising at 0.8.
Thank you. Perfectly done. See if you wrote something very, very close to that. Indicates that at equal to 5 or equal to 5 minutes, the temperature, can you see it's the slope, so it's increasing or decreasing. The temperature of the alloy, so a little more information, temperature of the alloy is increasing, because it's positive, at the rate of, if you did not use the word rate, it's still acceptable, increasing at the rate of 0.82 Fahrenheit per minute. That's how easy that is. All right. Question 2. I'm basically doing every problem in old. Oh, by the way, this is a practice test. The day before the test, you did this assignment. So it's almost a very representative of what you might see on that chapter. All right. Let's do part B, please. Part B says, find the average rate of change of WT from 4 to 15. How do we always do average rate of change? Is that MSEC?
Yeah.
He correctly, Campos calls it MSEC. So is that,
Wait, class.
yeah, he's, I think it's called FaceTime. So is that basically W of 4 minus W of 15 over 4 minus 15? Keep in mind the Y values on top. So what am I writing? 57.1 minus 67.9 over negative 11. Correct? Is that Lozano? Yeah, he was absent. Yeah. Negative 9.2?
Sure.
Oh no, negative 10.8. Correct? Negative. Oh, negative 11. So negative 108 over 110. But again, that's not very important. you can leave it alone. What are my units on top? Degrees Fahrenheit over minutes. Is that clear? So it says, the question tells you exactly what to do. Show computation that lead to your answer, use proper units. You lose points, you are familiar with the grading. You lose points if you're just not following instructions. Okay, let's have a look at C, please. Okay. Read part C. C says, why must there be a time in 0 to 20 where W, which is the temperature, should be 60 Fahrenheit sometime along the line? What concept are you using? W should be 60 sometime. Why?
Because
Huh?
it's
He says, is it MVT? It's IVT. We just have the W function. We're not taking derivatives, you know. We're not doing slopes. So if it's continuous, and that's 55, 57, 61, somewhere along the line should I not have hit 60? So that's a simple IVT. So let's write a thing. So I'm going to, since W of t is differentiable, continuous over, sorry, you said continuous, right? It's continuous over 0 to 20, because the IVT just requires continuous. But keep in mind, we discussed it yesterday, it was differential, it will be continuous here. Since W of t is continuous over 0 to 20, and, see if this comes back from the IVT chapter lesson we did a couple of days ago, and W of 4 equals 57.1, does it come back to you? We showed the work. And W of 9 equals 61.8. Who remembers what we write next? Thank you. There exists at least one T or one C, it doesn't matter, it's not a very big deal. In careful, which interval? 4 to 9.
Yeah.
There exists at least one C in the interval 4 to 9, such that we'll write an inequality. See if that comes back. W4, which is 57.1, less than or less or equal to W of t or WC equals, was it 60? Or W of t is less than W of 9 equals 61. So again, the theorem that does not require you to take derivatives, it's just W of t should be somewhere, you just use IVT. Okay, and the condition is only continuity, and we're good to go. So don't mix that up with this problem. Have a look at D. Have a look at D. Yes, ask me.
Does it matter if you have the or equal to?
No, it's not a big deal. No, it's okay. Now read D, please. D is a slightly different problem from C. D says, why must there be a time in 0 to 20 where W dash of t should be 4/5? All right? Is that obvious that I'm taking derivatives of the function you gave me? So that's the MVT guy. Who remembers what MVT says? Louder? Yeah, but he's telling me the condition. He says it should be differential and continuous, or continuous and indifferentiable. And then what does it end with? It says that m sec equals m tan. Okay, and they're saying 0 to 20. You don't have to do too much math. They kind of guide you. They say 0 to 20. We could conceivably take slopes, but they say 0 to 20. Just stick with that slope, all right? So I'll call it out. Since W of t is since W of t is continuous over the closed interval 0 to 20 and differentiable over the open interval 0 to 20, there exists at least a 1t in the interval 0 to 20 such that, just write exactly that, m sec equals m tan, and then show the work. They helpfully gave us 0 to 20. So what's my work on the left hand side? W of 0 minus W of 20 over 0 minus 20 should be equal to W dash of t. Okay, that's m tan, or a dash of x. Okay, what's W of 0? What's W of 0? Minus all over negative 20. And what's 55 take away 71? That 4/5. Therefore, We're done with the problem. We've demonstrated. Just make a note on the side by by MVD. Where's that part of the problem? Okay. So once again, everybody, put your pencils down so I can discuss finally what's the difference between IVT and MVT. For IVT, you just take that function. Is that clear? Just see, do we have a value in that interval? That's IVT. MVT deals with the derivative of that function. Is that clear? So assume for a second, I have to discuss this in BC also. Assume that it's W dash of t. Look at me, please. This is important. Then the question will say, why must there be a t such that W double dash of t? Is that obvious that taking the derivative of that guy? Okay, that's fine. You just deal with MCQ rules and the answer will show. All right. Let's do E, please. All right, we'll do it. It's not a very, very important problem. It says to estimate W of 10, write a tangent line approximation for W of t. Okay, so we're estimating W of 10. Okay. We're estimating W of 10. So should we first write the general tangent line approximation formula? Use the letters W of t. So what's the formula I'll use? W of t equals, guys, we're estimating W of 10. So what should A be? For those of you who didn't get it, the value at which we estimate, that's X. But the guy close to it, that's A. So what should I choose A to be? 9. So W of 9 plus W dash of 9. T minus 9. Okay, get the letters correct. We're using W. For those who say, I have no idea what you're doing. Remember, f of x equals f of a plus f dash of a, x minus a. You should be mentally, write that down also. Because some of you are like, huh? You must be mentally comfortable, nimble, agile, that you can say, usually it's f of x, but that's W of t, so I'll take the letters in one. Can you plug it in? What's W of 9? 61.8. Which smartphone will tell me how to find W dash of 9? Some kid whispered it. How do we find W dash of 9? Find the slope. How do we do it? MSEC, exactly. So is that 67.9 minus 61.8 over 15 minus 9? Because I went this way. Okay, 15 minus 9 and then t minus 9. Let's simplify this as best as we can. Is everybody understand what we're doing? We had to find W dash. Well, we just do MSEC, right? Is that what? 6.1? And that's 6? Not too bad. Okay. Like 1.1. And then what do we need to estimate? W of 10 equals 61.8 plus 6.1 over 6 times 1. You can do fraction trick, but overall that's the idea. Okay, F. No, let's skip F. I'm not going to ask a question like F on your final. Not now. We'll come back to it when you're doing a review for the AP exam. Okay, that's a calculator problem. Let's do a calculator problem. So turn on your calculators. So, Ms. Rava, the thing you want to write is underestimate or overestimate using tangent line approximation. Let that be the phrase. That will remind you. Under or overestimate using tangent line approximation. AB or BC, go. Well, BC also. BC especially. That's flagging for your final. So tangent line approximation, under or overestimate. Okay. Copy down the function. Oh, by the way, they gave us a derivative. So are we good to go basically? Okay, they gave us a derivative. So you'll get one question, calculator problem, one of these. It could be one of these. All right. Let's do a couple of parts so you get a feel for this. So enter the function in your calculator. Don't forget old rules. When you type sin x, hit right arrow to come down to negative x. Yes. So you should be dangling on top. Should not be graph mode. Yeah, guys, clear F1, F1, F2, F3. We what is it? Control tab or tab? Which was the command that actually quickly went to F1, F2, F3?
It was tab.
It was tab. Okay.
You push menu, and then push 1, and then push 4, and then push enter. It clears everything on the
It's a lot.
If you just triple click delete,
Huh?
if you just triple click delete,
Double click delete.
triple click delete on the graph, it'll give you an option to delete everything. You just go.
Oh, okay.
You can do that too.
Okay, guys, clear and delete F2, F3. They should be not. They should have. You should have only one graph. Is that clear? You should have only one graph. Clear or delete your other graphs. All right. Now let's have a look. Shh. Try this by yourselves. See if you can answer this yourselves. It says we'll assume 0 to 10. Okay, it doesn't say that. We'll assume 0 to 10. See if you can do this yourselves. We're calculating the relative min and max. Think about this is the f dash curve. So what should we do? Find the relative extrema from 0 to 10. What the
No,
hell?
that's supposed to be quick. Just press enter.
Alright, guys, by yourselves, from 0 to 10. Miss Tran gave us a shortcut of the window. What is that window thing? Oh, if you go to window graph,
Press enter.
you can say, you can restrict it to say maybe -2 to
Do something with that.
12.
No, you, like, go to.
Okay, if you use the window command, it will narrow down the domain. Okay.
Mr. Ramaswamy, it's not showing up. I don't know what I did wrong.
I have no idea. I'm gonna just reset it. I don't have time to investigate what's really happening. Just wait for it to open. Okay, those of you wrapping up the problem, because guys, start to finish, you're given 2.5 minutes to do this problem. It's multiple choice or 2.5 minutes. First of all, is that a relative min or relative max? Max. Or at 2.63. Is that clear? It's a gimme question. Since changes from positive to negative. Is that clear? Please do your weekend homework. This is one of the final reviews for this chapter. Okay, that was part A. Let's do part B. It says identify the interval over which it's increasing or decreasing. Can we just answer that quickly now? Okay, so it is increasing from 0 to 2.63, stupidly simple. Decreasing from to 10. Okay, since f dash is greater than 0, since f dash is less than 0. Mr. Compos, you're with us? Okay. Everybody okay there? Okay, now let's do some trickier questions. Let's do concave up and concave down. But let's just focus on, say, concave. It has multiple intervals. Let's choose the first interval where it's concave up. So pay close attention. We'll do the first interval, if any, where it's concave up. Oh my god, it's so... Okay, let me make it easy. First interval where it's concave down. Okay? First interval where it's concave down. It's kind of very gentle. So we'll do the easy one. The first interval over which it's concave down.
How nice of you.
Okay.
Is it 1?
So the logic is this. Shh. I have the f dash graph. If it's concave down, should our slope be negative? So am I basically saying where where the graph is decreasing? So see which is the first interval over which the graph is decreasing. Yeah, so you need the maximum value. How did you get this?
It's 1.16.
The y value is probably
No, you have to bring it down. Oh shoot.
Yeah, press it down. Come on, Vicky, that's my mistake.
Come on, Vicky.
Okay, okay, guys, for those of you conceptually lost, if it's concave down, this graph should be decreasing. So find the first maximum and the first minimum. Is that clear? Those of you way ahead, we're focusing on concave down. What did you guys get? 1.162.
Okay, now.
7.44. We'll wait for others to kind of confirm it. Don't copy. Actually work it. If you disagree, let me know. We may come to a consensus. We're okay?
I disagree. Maria has a question.
Yes, Ms. Louise.
You're in degrees mode.
You're in
Push
degrees
menus, go to 8, and then in the second, push menu at the bottom, number 8, and then there's angle and graphing, put it in degrees to radians.
Guys, kids are saying it's actually 6 point something. Miss, here's the reason. Miss.
Told you I disagree.
Okay, Miss, here's what. Miss Basu, because the stupid graph actually goes like this and like this. You have to be very careful. It actually attains a minimum further. I mean, further down. You don't have to go that far up. That's why. Okay, 6 point. 2.8. Okay. Yeah, I realized. I looked at the graph. Oh my God! I said it's a very gentle thing. You have to be careful, guys. I want you to relax. On your final, will be a fairly clear curve. Is that clear? It's not going to be like confusing. You can mix up, but the concept is more important. Is that clear? Sorry, go on.
Isn't there a second comp?
Yeah, you're right, but I said the first one. Just tell us the first one. So did everybody get the hang of these kind of questions? All right. Let's move on. So you'll see one question like that.
No, you have the right one.
For number 3, what should I do first with number 3?
Zoom in.
Find f dash, then plug it in and deal with it. All right. Okay, we'll do number 5. Okay, stay with me, please. Again, what you're learning is basically algebra to see if you're comfortable. So read the question with me. This kind of question has come both in multiple choice and FRQs, but a very simple question. It says, find the intervals over which that function is increasing and decreasing, then state the relative min and max. Stay with me, do not fall behind. Write on number 5, please. I'll do compose as solid. We're right here.
Oh, he's not on fun anymore.
He's not?
No, it died. It's okay.
I'm good. As a
Okay.
As a prank, what I ought to do is write down crazy problems. And poor Compass will say, maybe those are the months I missed. Crazy stuff. So make sure we are going to do sine radical log x over. It's like, wow, there's an x here and a theta there. Like, whoa.
That's baby food.
Wow.
What does that even mean?
That's like it's easy.
That's
Okay.
That's baby food. That's baby.
All right. Focus, please. Focus. So who remembers how we do in general? Ignore the question in general. If I want to know a function is increasing, what do I do?
Find f dash.
Dash greater than 0, number line. Thank you. It's a simple question. We should be able to do number line. All right. So let's do f dash.
I know.
Then you got to write
10n minus 1.
Okay. Who remembers what we always do next step? If you have a dangling expression like that. LCM. You must take LCMs.
LCM.
So what is really my top? Over x.
Yes.
What could I do on top? For those of you wondering why, remember we're taking number lines. 10. So if you're smart, what would I do next step? No, look down, look down. What do I do next step? Thank you. Difference of squares. So what am I really writing? Minus radical 2 x plus radical 2. You must be comfortable doing difference of squares are crazy, guys. Okay. Let's see who's sharp. Which is the only value of x we are interested in? Okay, I'll tell you the answer. You tell me why. I'm only interested in radical 2. Why?
Oh, because it's over.
Now you only negative.
But I didn't give any range.
Oh,
Pay attention, pay attention, pay attention, pay attention. ln can't be negative. You're calculus students, you must be aware of the domain. It is an ln function. So if you do, guys, look at me. Shh, this is important stuff. If you forgot to restrict the domain, make a note to yourselves. That's x is greater than 0. You need to be aware of the domain. And you write actually multiple intervals. I'll mark you down, like I'll give you 0 on the problem. So the correct answer is really, you have radical 2. There is no 0, remember. The denominator technically has a root of 0, but x is greater than 0. And now it's simple. What do I start with? That's it. There's nothing else going on. All right, so write down increasing interval from to infinity, decreasing from 0 to radical 2. Why? Because there's a domain issue. We can only take values beyond 0. And then we have a relative minimum at x equals radical 2. Okay, let's do number 6. Okay, we did lots of these problems also.
You don't have someone to clear the board for you anymore?
No, Mr. Alvaro sometimes helps me. But he needs to be given instructions. Or Miss Christmas takes over. Okay, have a look at number 6, please. It says maximum and minimum values of the function over that interval.
Oh, maximum.
Say that loudly. And critical points. Don't forget endpoints. Because, guys, isn't this question sometimes written differently, Ms. Ochoa, as absolute maximum, absolute minimum? But if I say max and min over, it's understood absolute maximum, absolute minimum. So we do endpoints, critical points. Let's find critical points. So how do I find critical points? Okay. Tell me what to write. 2 minus, show the work. 9 times 2/3. It is smart to show the work. X to the power of advanced skills. Can we write 1/3 on the bottom directly? Because negative 1/3. Don't forget power rule. You lower, subtract 1, 2/3 minus 1. You should be comfortable with the power rule. So that is really 9 minus over x squared 1/3. What do we do next step? LCM. That should happen mechanically. It should happen mechanically. So my expression really is 1/3 minus 6 all over x squared 1/3. How do I find the critical points? So the denominator equal to 0 and the numerator equal to 0. We have slope being 0 or does not exist. So I'll show work that Mr. Alvaro suggests. F dash equal to 0. So 2x squared 1/3 minus 6 equal to 0. Guys, you're in calculus. You're expected to have slightly more advanced algebra skills. Don't shut down. Okay, just take the ball and run. Next step. Add 6. So x squared 1/3 equals. Last step. Cube raised to the reciprocal power. 3. So x is really 27. Are we interested in that? No, it's outside the domain, right? So, okay. And then f dash does not exist. Should we set the bottom equal to 0? Will that just be x equals 0? And that's not in the domain either. So we only care about the endpoints. Is that clear? I hope you understand the logic. So let's find f of negative 27. Rio Sweegle, I hope you're keeping up with your work. Okay. Keep up with your work. Keep up with your work.
Regularly, except I missed yesterday.
There was one kid. Was it in this class?
Oh.
I don't know. In one class, I said, "Oh, keep up with your work," and the kid said, "Oh, I've been consistent except yesterday." I'm thinking, okay, then that's not being consistent. I've been regular except yesterday. It's almost like, who was it? It was Sanchez. It was Sanchez. She's pretending it wasn't her. So it's like, who was it? So who was it? It's like, have you quit smoking? Yeah, I totally have quit smoking between puffs. So I've completely stopped smoking between, like, has your dad stopped drinking? Yeah, between sips. I stopped drinking because it's very hard to be constantly drinking. So I just take a break between sips. I don't know if Ms. Hernandez is laughing because from personal experience.
Yes,
No, it's pretty wide.
All right. Okay, let's move on. Stay with me. Let's plug in the endpoints. Okay, so again, but a fervent plea to Ms. Rios to keep up with the work. I put Ms. Marzuk in charge of Ms. Rios, but Ms. Rios is quite a bit of a rebel. So even though Marzuk reminds her, Rios like, okay, let's plug in negative 27. 2 times negative 27, I'll show the work. Minus 9 times negative 27 to the power of 2/3. It is smart not to skip steps, so actually you should plug in. Is that negative 54? Cube root of negative 27? Square it? So what are you really right? Minus 81. Is that negative 135? Do you observe when I don't write on the stupid this thing? When I write on the board directly, how neatly I write? Like some of you like, Ramaswamy is crazy handwriting. No, I'm capable of, really. They should make a new font, Ramaswamy. Okay, it's like, on UC apps, like, nah, I'm not going to use your stupid serif font or Times New Roman. It's like Ramaswamy.
This speaks otherwise.
Huh?
This speaks otherwise.
This speaks otherwise. It's a random scribbling. But some kid, I don't know whether it was now or somebody pointed out, like assume they're making a movie, like a math.
Said it yesterday.
Yeah,
And
in
first
class?
period. Yes.
In class?
Yes.
In first period? Or here?
In here.
In here? Oh, okay. But it still bears repetition. He says, if they make a movie, Ramaswamy, you should pose in front of the board. So anybody, like they take a film like that, whoa, what is all this crazy math? But then they have random Mr. Curry. Like probably he eats a lot of curry? He smells of curry? What's going on?
His first name is Bobby.
Whose first name? Oh, no, Bob, not Bobby. It's probably Robert. Bob. Probably not Bobby. Rajesh.
That's his real name.
That's his real name. Mr. Curry's real name is Rajesh. Okay, guys, what is the other guy we plug in? Negative 8. Okay, see, we can do that all by yourselves, John.
Oh, it was during lunch. That's what it was.
That's why. See, I knew it wasn't during
Spino was here.
Okay, guys, by yourself, negative 8, slow and steady, yeah?
17. I just.
4, 36. You know, negative 52?
Yeah.
Okay.
Correct.
So, absolute max of negative 52 at negative 8 and negative 135, was it? Okay, at negative 27. Is that clear? So again, if it says max or min value, it does not use the word relative. For those of you who tend to get confused, if it does not use the word relative, then it's an absolute problem. Critical points, endpoints. Okay, this was the question that some of you had serious trouble over. So we'll go over, we'll go all 4 parts. Okay, stay with me. Wait, stay with me, please. And guys, it requires a calculator. One way you take 30 seconds, enter that very carefully into your calculator. Into F1. So clear F1. Go on.
Remember to push the arrow.
Yeah, push the arrow to come downwards. Put parentheses on the denominator. Parentheses. Again, guys, denominator should get parentheses for pen dash to apply. 49e to the power of negative 0.1 x. Then hit down arrow, right arrow, close parentheses. The minus sign is the negative sign here. Do not mix up this sign with this sign. This is the negative sign you need. Go on. We don't care about the sketch. We're really not interested in the sketch. No, it's okay. Some of you are saying, oh my god, it's like a flat graph. It's okay. We're not even looking at the graph. I don't think for any of the questions, none of the questions we're interested in graph. Smart kids, switch to calculate mode. Just go to calculate mode. We are not interested in the graph. Don't be alarmed if the graph seems really flat. It's a logistic function. Okay. All right, now let's read the problem, please. Shh. I'm going to wait for Alfred. No pressure. All right. Read the question with me, please. Read the question with me. Shh. It says the amount of sewage in tons at a plant at any time is given by this. So think before you answer. Is this the original function or the rate function? Don't blurt out anything unless you can substantiate that. So read the question. So which guy is this? The original or the derivative? The original. How do you know? It does not use the word rate. It does not say changing at. Is that clear? So it's the original function. So let's write down. So A of t is the amount of sewage at time t. So it is important, we've gone over this concept, it is important to state the original function always. They don't give us a rate, so there's nothing involved here. Okay, part A. Part A says, at t equals 12, is the amount of sewage being processed increasing or decreasing? Do some calculation, tell me the answer, and then write a brief explanation. Do this all by yourself, start to finish. To help some of you, what notation am I using on my paper? What am I finding? A dash of 12. And there are some kids who have taught us shortcuts for the derivative. We can go to the book symbol, right? Guys, next to below delete, there's a book symbol. The one to the left of it, that's the derivative. You have to hit F1 of x. F1 parentheses x.
Yeah, the graph.
Guys, you have to type F1 parentheses x close parentheses x equals 12. Okay, those of you finished, check if you got 1.188 something. Yeah? Okay, I'm helping some kids because some kids have trouble with units. Is that another way to write that as dA over dt? So what are my units be? Read the question. Is it tons per day?
Yes.
Yeah, tons per day. Okay, write a brief answer to answer the question. You must have the word since or something over there that explains why your answer. So read the question, just write it down, take it from the question. It says, at equal to 12, is the amount of sewage being processed increasing or decreasing? Get it from the question. And don't forget to write the word since and write a brief explanation. You're not writing anything complicated. It's a very, very simple question. Those of you get it, those of you finish, what did you write? The amount of sewage being processed is increasing at t equals 12. Make sure you write at t equals 12. Since a dash of 12 equals 1.888, greater than 0. Is that clear? Make sure you write greater than 0. Okay, see if you can do B all by yourselves. A similar problem, but right. We did one interpretation earlier. I want to see if learning happened. See if all of you can do B all by yourselves. Yeah, you're doing B. Okay, write the question, answer it, write a brief explanation. Everybody is doing B, arch themselves. Make sure you write a sentence.
Interpret it, right?
Yes.
Oh. Remember how I told you I had a preposition?
Proposition?
What is it?
You know how you're writing on the board now? You can record the screen of the board, like on that computer, and instead of me having to do that, it'll just.
How?
There's this website like Screencast-O-Matic.
Oh yeah,
It's just a
yeah.
program.
Do you want to download it?
Yeah, well, we can do it
During lunch? Okay, the other thing I realized was this, that there is another way. Can you hit Control S? day space 74.
But they wouldn't put this one.
And no, it's yes. So here's another one, which is, I've thought about doing this, which is, I just download
Two
this.
and the zero?
Just send it to.
Yeah, no, I
I
download,
know you swear we like, is it like?
yeah, into the actual thing. Let me show you how it's done. PDF.
And then you can just save all of that and then send
Then
it
it's
to.
still wouldn't
Yeah,
be.
or actually dockets, look at the dockets. Dockets. So what does it do? So remind me to do that, right? And then enable editing. And I hit file, save as, and I save it as something called a stupid XPS file. Let me show you. First of all, save it on the desktop.
No, he took this out and then used it.
But I save it as some stupid file called XPS document. It's like a photographic document. Okay, save. Alright? Basically it takes a picture. And then I go here, and I go file, import. Ah! What the hell?
Yeah,
Where did desktop at?
click favorites.
No.
Maybe he just.
Click there. Click.
Yeah?
Actually, you can go to. Is it on the
Are you
desktop?
asking about the?
Yeah, desktop.
Yeah.
And then,
I
why didn't it? No, where is it?
Click this little arrow right here. There's not.
Why is the file? Resave. Why didn't it save? I thought we saved it on desktop. Okay, file, save as. Oh, it's under downloads. Okay. I thought it saved on the desktop. What? It's not on downloads either? What the hell is going on? Okay, fine, let's try again. Save as. Okay, save. See, it is under downloads
Here.
and desktop. So here's the downloads here. It is there under downloads.
No, that was the one that was the other one.
Yeah.
It's because the reason it wasn't showing up in your directory was different.
But let's have a look.
Yours was under.
So should I go here?
Yeah.
No, it's not.
Go to local disk. Go to users. J Ramaswamy. And then go to download.
Downloads? No, still not.
It's probably not an X whatever.
XPS? No, I did this on my computer and it worked. That's why I'm saying that it actually imports XPS documents.
Oh wait, go back. Hey, go to file type.
Oh yes! You're a bright guy. Yes, you're an XPS. Thank you. Okay, now let's go to downloads. Oh no.
You should take
Go to the other Where?
Take it next. Or you have to put it in the test. Because if you don't, it's going to say 0. That's going to bring up your grade level. Right? Is it 0 right now?
Still not? Just trying to find it.
Have it ready. Email him.
Okay, we played on it because I did it on my computer. And I was trying to actually, I shared it with Bill. So, go to mine. Oh my God, he's the next Virgin Mary.
Okay, no, I figured out what you said. So, because you took out the 10. And then,
Oh, so we took it to
so then 10 times 2 is 20.
It's obvious.
So the x minus 2 squared.
They're saying
I saw it.
Oh, yeah.
Those guys are okay, maybe find it.
But I mean, if you take out 10, can you just write x squared minus 10?
Let's say that is XPS.
That's why it's 20 minus
Okay, guys, let's move on.
You got like 5 minutes.
Okay, guys, shh. By the way, what is the answer to 8 of 5? What is the actual 5? He says 0.629, is that correct? Yeah. Okay, I'm going to interpret it for you, see if you wrote something very close to that. A-5 equals 0.629 indicates that the amount of sewage being processed at t equal to 5, or t equal to 5 earlier, is that clear?
Yeah.
At t equal to 5, the amount of sewage being processed is increasing at the rate of 0.629 tons per day. Okay. Let's have a look at C, please.
You
Everybody.
have to have the at the rate of, or that's.
Yeah, that's fine.
Okay.
You can say at the rate of, or you can just say at. It's perfectly fine. Both are acceptable. Okay, have a look at C, please. Read the question carefully. Psst. Observe the under bold word. At t equal to 12, is the rate at which sewage is being processed increasing or decreasing? So, what's being asked there? The second derivative. So it's the rate. This is the rate. Is the rate increasing or decreasing? So I'll take its derivative. So in your notebooks, C is a double dash of 12. All right. See if you can find this. Guys, on your calculator, do you observe there's a second derivative key? Okay. Yeah, is it there in that book command too? The second derivative key? Regular. Yeah, the thing is, yeah. Make sure you type F1 of X.
Do it separate. Yeah.
12. This is part C. Yeah, those files are already there. It's at 12, by the way. Shh. Ah, there it is. No, okay, no, guys, ignore the board, do the math. Those of you finished, what was A double dash of 12? 0.103. Guys, what are my units? Tons per day square. Okay, here's the explanation. Indicates that, I'm just calling it out, indicates that the rate at which, or you can just say rate of change of, all right, that's okay too. Because some kids have trouble with the English. You can just say the rate of change of the amount of sewage. Okay, indicates that the rate of change of the amount of sewage being processed at t equals 12 is increasing at the rate of 0.103 tons per day square. You fool, it was XPS, not
Is
XMS.
increasing at a
I
rate
think
of?
it's creating new
Is increasing
acronyms.
at. Yeah.
Wait, is it increasing at a rate?
Yeah, at the rate of.
Isn't that a bit repetitive?
It's perfectly fine. English-wise, it's perfectly fine. The rate is increasing the rate of. That's perfectly fine because we are taking double derivative. 0.103 tons per day square. All right. Now, Chrome, please.
That's probably
Okay. We know the last problem. Not there. Okay, last problem. Thank you. Guys, shh. Is D getting repetitive?
Yeah.
It's the same thing? But did most students understand how to interpret and do the problem?
Yes, sir.
All right, we're done. Because Nava is very impatient about playing.
No, it's just,
Yeah, I don't know why. Why it's not able to access it to like.
Okay, let's forget it. Okay, you got 10 for 20. So for 2. But 20 minus 2 is 10. Okay, early. Okay.
How many times is 10 going to 20?
2, but like
2 times.
but like that's weird because you're taking 10 out, so you have 10 left. Okay, I get it. I just gotta like tell myself that. So we took out stuff.
So you're pulling out a 10, so then that's 10.
Whenever you take out squares, you're basically dividing.
It's on the floor.
You do the square.
I know, but like, okay, then when you take it out, you're basically dividing. But like,
Like if you do, I used to let it go. Okay, so that one was
just 10x squared.
So then, since the numbers are really big, you could just like simplify it for yourself. So then, the number that goes into both is okay, so then you put it out.
Oh, but then there's a 1.
Guys.
Okay, yeah.
Guys, I'm okay. If you do not turn in yesterday's homework, Ms. Aldabulsi will send us solutions. So check. Guys, that was, guys, I'm perfectly fine to take it away for this reason. That was a chapter 2 test. So you want to see like, if you did right. Okay, feel free to take it back, please.
Thank you.
Homework. Keep up with your homework.
Or I'll just check my solution too.
What? Well, I'm coming back. I just had to get my phone.